All right, so today we're going to talk about the product property rules for, or all the property rules, I should say, for logarithms. There are only 3 of them. And once we do that, we'll take our break for lunch, and then we'll come back and we're going to graph logarithms. So we have 2 major topics we're going to do today. So the product property, product of course means multiplication. So the product property says that if you have log base b of 2 things being multiplied together, you can separate them as log base b of m plus log base b of n. Okay? Now, this property goes both ways. So what we're going to do is we're going to learn how to take multiple logarithms and condense it down into one. And then we're going to take one logarithm and break it up into 2 or maybe even 3. All right. So the way the property works, if you're starting off with 2 logarithms, make sure the logarithms have the same base. So I have a log base 2 plus a log base 2, which means I can condense it to 1 log base 2 with 7 times 4. Now, if you can clean this up, which we can multiply that out. Our final answer would be log base 2 of 28. So that is what it means when they ask you to condense into a single logarithm. You have multiple logarithms and you're trying to use these properties to condense it into a single logarithm. So here I have a log plus a log. What's the understood base when you don't see one? Not 1. 10. 10. Understood base is 10. So both of those have little 10s right there, but you're not ever going to see them. Okay? So I have a log plus a log, so that allows me to condense it to 1 log base 10 of 25 times 4. And then I can multiply my 25 times 4 and get log of 100. In the third example, I have log base 4 plus log base 4. That allows me to write down 1 log base 4 and then multiply the numbers together. So I'm going to multiply 2x times 4x squared. So that gives me log base 4 of 8x to the third when you multiply those 2 terms together. So that's what it means to condense. You're starting with multiple logarithms, but you're condensing it into a single logarithm. Now, we're going to use the property and we're going to expand, which means you start with 1 logarithm, but you end up with 2. Okay? Now, the catch here is they didn't tell you which factors of 6 to use. So you've got 1 times 6, and you also have 2 times 3 that you could use. So I'm going to do them both because it doesn't specify. Usually when they have a number like this, they at least tell you to use 2, or they'll tell you to use the 1 and the 6. They'll tell you which combo they want. So if we use the first combination, that becomes log of 1 times 6, and then I can split that into log of 1 plus log of 6. But I have to create the multiplication situation. Or if we use the 2 and the 3, that would be log of 2 times 3. I change 6 to 2 times 3. And then I can split that to log 2 plus log 3. So we have a couple of options. Do you have to do both? No. But more than likely, they'll indicate which combination they want you to use, whether it's the 1 and the 6 or the 2 and the 3. Now, for 45, I'm just going to use the most obvious. Every time I see 45, I think 9 times 5. Are there other things that multiply up to 45? Yes, but that one to me is just, it just jumps out at me. So I'm going to rewrite this as 9 times 5, and then I'm going to split it. I'll have a log base 7 of 9 plus a log base 7 of 5. Now in the last example, I have 5 times x. So if you want to think of that with the multiplication dot, that's actually 5 times x, and then you can split that into 2 logarithms, log base 2 of 5 plus log base 2 of x. So we've done a couple condensing and a couple of expanding, and these are basic ones. When we get finished with this page, we are going to go into combining all of them together. So our quotient property, notice that this time I have a fraction, and that's what a quotient is a fraction. So when I separate those logarithms, I'm going to have log base b of m minus log base b of n. So when you have a fraction, you separate them with subtraction. Now, we're going to do the same thing. We're going to take 2 logarithms, condense it into 1. We're going to take 1 logarithm and expand it into 2. So since I have a log base 3 minus another log base 3, as long as I have the same base, I can condense it into 1 log base 3 with a fraction behind it. That would be 24 over 8. If you can reduce it, great. If you can't, it just stays that way. But we can reduce this. Log base 3 of 3. So we can actually reduce that down. In number 8, I have a log base 2 minus a log base 2. So that allows me to write 1 log base 2 with a fraction behind it. So I'm going to have 15 divided by 15. And that, of course, reduces down to 1. And then in example 9, I have a log base 4 minus a log base 4. So I'm going to have 1 log base 4 with a fraction behind it. X to the 9th power would be my numerator. X squared would be my denominator. And then I can reduce this by using my exponent rules to x to the 7th. Take that 2 up and subtract it. That's what your exponent rule is. Now, if y'all have any questions, y'all stop me along the way. So now I'm going to go in the opposite direction. I have a number, and I'm going to split that up. Okay, I'm actually going to do 11 and 12, and then I'll come back and get number 10. So since we have a visible fraction, I can turn that into 2 logarithms, log base 5 of the numerator minus log base 5 of the denominator. Number 12, I have the log of a fraction. So I get log of the numerator minus log of that denominator. Now, in number 10, it asked me to use this quotient property to expand that, but I don't see a fraction. Okay, so I need to come up with fractions that would divide out to a 4. So 8 divided by 2 is 4. Do y'all agree? 12 divided by 3 is 4. 16 divided by 4 is 4. 20 divided by 4 or divided by 5 is 4. Do y'all agree? So I've got all kinds of them to choose from. I'm just going to use the first one just for the example. So I'm going to rewrite this as log base 8 of 8 divided by 2, because this number still has the same value as 8 over 2. And now I can split that up into log base 8 of the numerator minus log base 8 of the denominator. Any questions about the product property or the quotient property for logarithms? All right. Now, the power property is my favorite because to me, it's the easiest one of all of them, because it says if you have log base b of m raised to a power, i.e. the power property, I can take that power and put it out in front as a multiplier. So I'm going to take the power and multiply it by log base b of m. Now I can do that backwards. If I have a multiplier, I can turn around and I can move it back as the exponent. So all of these properties go both ways, forwards and backwards. So we are going to condense into a single logarithm. So that means take your multiplier and put it back as your exponent. So that would be log base 4 of 2 to the 5th power. And 2 to the 5th power is 32. So I took my 5 and moved it up as my exponent. So basically that's what you're looking at. And then 2 to the 5th power is 32. On number 14, I'm going to take 7 and move it up as my exponent. So I get log base 2 of x to the 7th power. I can't simplify that, so it just stays x to the 7th power. Now, put a star by number 15 because we do have a fractional multiplier, and that causes some issues. So I have 1/3 as my exponent. So that would be log of 8 to the 1/3 power. Now, when you have a fractional fractional exponents represent radicals. So the rule is if you have a number raised to any fraction, that becomes the nth root of that number. The denominator becomes the index of the radical. So in this one, our denominator is a 3. So I actually end up with the cube root of 8. Okay, so just remember, if you run across fractions either as the power or the multiplier, there's going to be a radical involved. Okay? Now, we're going to do just the opposite. We're going to take our power and just put it out in front as the multiplier. So 7 times log base 2 of 8 for number 16. Now, number 17 is a little bit tricky because you already have a multiplier out there. So I'm going to take whatever my exponent is and I will multiply it by whatever is already out there if there's something. So technically, I've got 3 times that exponent, which when we distribute our 3, we get 3x minus 3 log of 4. Now, I see a radical, so I'm going to have to convert that to a fraction. What is the index of this radical? Because I don't see a 3. What's understood to be the index? A 2. Okay, so the square root of w turns into w to the 1/2 power. So that would be log base 7 of w to the 1/2 power. And that 1/2 will go out in front as the multiplier. So anytime you see those fractions, anytime you see those radicals, you have to relate those back together. Any questions about the basic properties? Because the next page, we're going to combine a whole bunch of stuff. Everybody get what you need? Okay. All right, so does your next page say putting it all together? Make sure we're all on the same page. Is that right? So if you notice for the directions, it says rewrite as a single logarithm, simplify if possible. Okay, so if you notice in every single one of these problems, these first 8 problems, you have multiple logarithms. Our final answer will have one logarithm in it. Okay, so the first thing I want to do when you are rewriting as a single, deal with your powers first. If you have any powers that need to be, or the power property, if you've got any multipliers that need to be put back as powers, do that. So in number 19, I have 2. So that's my only multiplier. So I'm going to use my power property. So that would be log of 6 squared minus log of 9. Well, I can actually simplify 6 squared. So that would be log of 36 minus log 9. 6 squared ends up being 36. And now I have a log minus a log. So when I write this as one fraction, should I multiply 36 and 9 or divide them? Divide it, because it is subtraction. Since I can divide 36 by 9, I get log of 4. And that would be my final answer. If you can't reduce that fraction, it's okay. It just stays the unreduced fraction. All right, in number 20, the first logarithm has a multiplier, and so does the second logarithm. So I'm going to deal with those first. I'm going to take 2 and write it as my exponent, or 4 and write it as my exponent on the first logarithm. I'm going to take 2 on the second logarithm and write it as my exponent. I can only do this as long as those base numbers are the same. Now I have a log plus a log. So do I multiply or divide? Multiply. So I'm going to multiply this number times this number. So I have a parentheses with a to the 4th times b squared in it. Now, you don't necessarily have to show the multiplication dot. I'm just showing it just to make sure we're all on the same page with the multiplying. In 21, I have multipliers. So I'm going to take my 7. I'm going to put that up as my exponent. You always check for those powers first. So I'm going to take log base 4 of u to the 7th. You have to be careful with this part because I am going to take the 3 up here and I'm going to multiply it by the exponent that's already there. So 3 times 2, so change that exponent to a 6. And now I can condense it down to one logarithm, but will that logarithm have a multiplication or a division behind it? division. Oh, that's a V, I apologize. Now, you can't reduce a u over a v, so it will just stay log base 4 of u to the 7th divided by u, or v to the 6th. Now, they start getting a little more challenging because this time in number 22, we have a log plus a log base 2 minus a log base 2. So you have a log base 2 plus a log base 2 minus a log base 2. So what we're going to do, there are no parentheses, do y'all agree? Like there is in number 24. There are no multipliers, do y'all agree? So I don't have to worry about my power rule. I'm just going to go straight across. So the first thing I'm going to do is condense these two logarithms by using the product property. So that would become one logarithm with 4 or 15 times 4, which becomes log base 2 of 60. Do y'all agree with that? All right, now I'm going to bring this one down, and I will apply my quotient property because I have a log base 2 minus a log base 2 now. So this turns into log base 2 of 60 divided by 6, and that would reduce to log base 2 of 10. Any questions about that one? All right, in number 23, I don't see any parentheses. I'm going to save number 24 for last, but I don't see any parentheses. I do see a multiplier. I do see a fractional multiplier, which means there is going to be a square root in my future. Okay, so if I take this multiplier and put it back, I have log base 3 of 4 plus log base 3 of y plus log base 3 of 49 to the 1/2 power. Now, I'm going to come up here in some workspace. 49 to the 1/2 power is the same as the square root of 49. That denominator becomes the root, so that would make it a square root. And that would equal to what? What's the square root of 49? So all of this, I have log base 3 of 4 plus log base 3 of y plus log base 3 of 7. So I simplified that last logarithm as far as I could go. I have a log plus a log. So when I do these two together, I condense that to log base 3 of 4y and then I have another plus log base 3. So I'm going to do the product property one more time. And that gives me log base 3 of 4y times 7. And I apologize, I ran out of room. My final answer would be log base 3 of 28y. 4 times 7 is 28. Do we need to go back through any of that for anybody? All right, we're going to jump over number 24. We are going to come back to it. So in number 25, I have 3 times log base 2 of 4 and then log base 2 of 32. First thing I'm going to handle is that 3. So that gives me log base 2 of 4 to the 3rd minus log base 2 of 32. I can actually multiply that number out. 4 to the 3rd power is 64. I can condense that down to one logarithm. log base 2 of the fraction 64 divided by 32. And that ends up reducing to log base 2 of 2. 64 divided by 32 is 2. Any questions about that one? All right. In number 26, do you have any powers that you have to deal with? Okay. So we have a 2. I have a 1/2 or a 1/4, I apologize, which means I'm going to end up with a radical. When your multiplier is a fraction, that represents a radical. So I'm going to have log of 6 squared, which becomes log of 36. All right, what is that, lunchtime? All right, so we will pause here and we will finish that problem. We will start it over.